Alright, our next video we're looking at learning how to take out a greatest common factor, but I am going to call it GCF just because make it simplify a little faster. So let's go ahead and go to our page. So first thing we got is the greatest common factor. Common factor is a factor that divides two or more. I'm going to add that. Numbers or factors. Okay, so that's just the basic definition, and I'm sure you guys have seen this before, but it's a little different with quadratics. So here's the problem you guys have probably seen before, is just find the greatest common factor, or the GCF, of 12 and 16. So we have 12 and we've got 16. Let's go ahead and list some of their factors. So with 12, we've got 1 and 12. We've got 2 and 6. And we have 3 and 4. Okay, that's all. And then 16, we've got 1 and 16. We've got 2 and 8. And we've got 4 and 4. So looking at all these factors, we have to see, okay, well, which ones match? Which ones are the same? So in 12 and 16, they both have a 1. They both have a 2. And they both have a 4. So to find the GCF, you're obviously looking for the largest common factor. So the largest common factor is our 4. So our GCF in this problem is 4. Okay, so that's probably the problems you have seen before. But here's what one would look like using quadratics or factors. So you have two terms. You have a 4x and a 6y. Okay, well, let's look at that number out front. We have 4 and we have 6. Well, factors of 4 are 1 and 4 and 2 and 2. And factors of 6 are 1 and 6 and 2 and 3. So your goal is to figure out, okay, well, which one do they have in common? They have 1 and 2 in common. So our GCF is 2. Well, if we wanted to factor that GCF out, you're going to divide each term by that GCF. So we have 4x plus 6y. Well, I'm going to divide both of those terms by 2. Well, 4x divided by 2 gets us 2x, and 6y divided by 2 gets us 3y. So that's what's left over, and we're just going to put our GCF out front, and that is how using GCF. That'd be our answer. Okay, let's go to number 3. Let's see, where'd it go? Alright, so number 3. It's number 4. There we go, there's number 3. So we have 3 different terms in this problem. We have 6, -9, and 12. Well, feel free to list out each factor of 6, 9, and 12 and see which one would be the greatest of them all. But that would probably take a little bit of time. So we're going to start thinking logically about these kind of problems. Well, I have 6, okay. I have 9, and I have 12. Well, if you're just, you could either look at a multiplication table or something, you would have the realization that, oh, well, each of those numbers can be divided by 3. So that's going to be the GCF that I'm going to take out here, is a 3. And then also I'm going to look and see, oh, well, each term has an x on it. Okay, well, this first one has 2 x's, the second one has 2 x's, and the last one only has 1. So if I had to pull the GCF out of the x's, your goal is to figure out how many of those x's could I take away. So for the first term I have 2, the second term I have 2, and the last one I have 1. So out of all of those, the most I can take out is 1, because I cannot take 3 out, or I cannot take 2 out of the third term. So I'm also going to take out a 3x. And then your goal is to figure out what is left over. And that's what will stay in parentheses. So remember, since we found what our GCF is, we're going to divide each of those terms by 3x to find out what is left over. So when I do my first one, so I have 6 divided by 3. Well, that gives us 2. And then I have x squared divided by x. We're left over with x. So that's our first term. Our second term, we've got -9 divided by 3. So that gives us a -3. Then we have x squared divided by x. That gives us an x. Done with our second term. And then our last term, we've got 12 divided by 3. That gives you a positive 4. And we have x divided by x, which they just cancel out. And you're left with 4. So the last thing you'll notice in this problem is we have some like terms on the inside of our parentheses. So we'll still have our 3x outside. Lastly, we just need to combine those two on the inside. So that's 2x minus 3x. So we get a negative 1x plus 4. And that is our answer. So our GCF here was 3x. That was our GCF. So our greatest common factor out of each term. All right, number 4. We only have 2 terms in this problem. We've got 16x squared and negative 8x. So again, you guys can write out the factors if you want to see which one's the GCF, or you can just think about it. So you know that both are even, so they divide by 2. So we could go 2. Let's go a little bit higher than 2. Let's go 4. Okay, well that would divide both. 16 and 4 gets you 4, and 8 and 4 gives you 2. Okay, well let's keep going. Let's go to 6. Well, that doesn't divide either of them. Okay, well let's go to 8. Oh, well, definitely 8 divides 16, and 8 divides itself. So we know our number here is going to be an 8. And now let's look at our x's. So our first term has 2 x's, and the second has 1. So if I need to take out a GCF for my x, I can only take out one of those x's. And then the rest you just have to leave left over in your parentheses. So remember, we've got our 16x squared minus 8x. We found our GCF was 8x. So that means we have to divide each of those terms by 8x to figure out what's left over. Well, when we do that, we see we've got 16 divided by 8. That gives us 2. And we have x squared divided by x. Well, that just leaves us with x. And then we'll subtract. 8 divided by 8 gives us 1. And our x's will cancel out. So our answer here is our 8x, and then left over 2x minus 1. Looking pretty good. We've got 2 more left. What I want you guys to do is kind of break this up into parts for number 5. There are 2 different factors. We have this first set of parentheses and then our second set of parentheses. Well, I'm going to treat these like they're completely separate. So I'm going to look at 9 and 12 first. So again, you can list out the factors, or you can just think logically, and for this problem, we're going to see that 3 divides both of those numbers. We're also going to look if we can take out a GCF of x, and we can't because our second term 12 does not have an x on it. So we can go ahead and divide each term by 3, and left over we'll have 3x plus 4. Because 9 divided by 3 gives you 3, and 12 divided by 3 gives you 4. So that's our first term. Now let's go ahead and look at our second. So I have our 4x, and I have 16. Well, what number divides 4 and 16? Okay, well 2 does, because they're both even, and 4 does, because 4 divides itself, and 4 divides 16. So we're going to be taking out a 4. Well, let's see if we can take out any x's. Can we? No, because the 16 doesn't have an x. If it did, then we could, but since it doesn't, we'll just go ahead and figure out what's left over. Divide each of those terms by 4, and we're left with x plus 4. Because 4 divided by 4 gives you 1, so it's like having a 1x here, and 16 divided by 4 gives you 4. So now we have our 2 separate things, but we need to combine them. We've got a 3 as our GCF and a 4. Well, let's go ahead and multiply those, and you'll get 12. And then go ahead and put what you had left over, which was your 3x plus 4, and your x plus 4. So that is how we'd simplify this quadratic using GCF. Alright, we have one more problem, problem number 6. Go ahead and pause this video, try it by yourself, and then you can check your answer. Alright, this is what your problem should look like. You see that you've got three terms. You got 15, 30, and negative 45. And you can see that 15 divides each of those factors. So we would divide each term by 15. Well, before we do that, let's go ahead and look at our x's. So you can see that the first one has 7, the second term has 6, and the last term has 3. So we can see that we could take 3 x's, so x to the third, out of each term. So our GCF here is 15x to the third, and then you got to divide each term to figure out what's left over. So 15 divided by 15 gets you 1, and you've got 7 x's on the top, 5 on the bottom, you have 4 left over. Our middle term, we have 30 divided by 15, which gives us 2. You got 6 x's on the top, 3 on the bottom, you can see that you'll have 3 left over. And then our last term, you got 45 divided by 15, which gives you 3. And then our x to the thirds will cancel out. So you're left with this answer as your simplified quadratic. All right, go ahead and cross off the booklet assignment for it. And go ahead and get started on your worksheet. And if you have any questions, please let us know. Good luck.